Next experiment. The aim of this experiment is to study the effect of spasmogens and relaxants on rabbit's intestine.
The objectives of this experiment are to understand the terms spasmogens, spasmodics, spasmogenic and antispasmodics or spasmolytic or spasm relaxants, to understand the phenomena of peristalsis, to understand the terms spasm, tonic spasms, atony, cramp.
So next is the requirement of today's practical. So first animal, rabbit, then PSS, that is physiological salt solution, thyroid solution, then drug acetylcholine in the concentration of 1 mg per ml, instruments or equipments in that Sherrington's rotating drum, student's organ bath, aeration tube, aerator, frontal writing lever, stand, clamps and plasticine wax.
Spasms characterized by sudden and involuntary increase in constriction of smooth muscles. Spasmogens are agents which initiate muscle spasm. Relaxants are agents which decrease tone of smooth muscles. In intestine, presence of food triggers neural and central parasympathetic reflexes, causing contraction resulting onward movement of food bolus.
So theory behind this experiment in that spas nothing but the sudden and involuntary increase in constriction of smooth muscles, and those substances which initiate the smooth muscle spasm that we called spasmogens, while those agents which decrease the tone of smooth muscles, that is known as relaxants. In intestine, the presence of food which may triggers neural and central parasympathetic reflexes, which causes contraction of smooth muscles of intestine, resulting onward movement of food bolus. That means foods becomes moved onward side. Next.
Obstruction in intestinal lumen is painful and results in cramp known as colic. Loss of peristalsis is known as atony of intestine. Spasmodics initiate smooth muscle contractions and restore peristalsis. Smooth muscle relaxants like papaverine and adrenaline reduce tone, force of contractility and induces relaxation. Acetylcholine increases tone and force of contraction of smooth muscles of intestine through muscarinic receptor and is spasmogenic in action. Atropine-like parasympatholytics nullifies spasmogenic effect of acetylcholine on muscarinic receptor and acts as spasmolytic.
So in theory, there are some phrases which are very important, that is colic, atony, spasmodics, spasmogens and spasmolytic. So colic means the obstruction in intestinal lumen is very painful and results in cramp, that known as colic. Then what is atony? The loss of peristalsis movement is known as atony of intestine. Then spasmodic initiate smooth muscle contraction and restore the peristalsis movement of intestine. Smooth muscle relaxants like adrenaline and papaverine reduces tone, force of contractility and induce relaxation. While acetylcholine increases tone and force of contraction of smooth muscles of intestine by acting on muscarinic receptor and is spasmogenic in action. While atropine, like parasympatholytic drugs, which nullifies the spasmodic effect of acetylcholine on acting on muscarinic receptor and act as a spasmolytic. Now we will discuss the procedure of today's practical. So look the procedure. So first, clean the content of jejunum with thyroid solution in a syringe and avoid any damage to smooth muscles lining of jejunum. Then next, take 2 to 3 centimeter long piece of jejunum and ensure the lumen of jejunum is clean and open. Then next, tie the thread to top and bottom ends of jejunum loosely and ensure the lumen remains open. Now mount the preparation in organ bath containing thyroid solution and maintain the temperature of water bath at 37 degrees centigrade, as well as aerate the muscle preparation with aerator. Now stabilize the muscle preparation for 30 minutes under a tension of 0.5 to 1 gram. During stabilization, wash it with fresh quantity of thyroid solution for at least 4 times. Now start the drum. You will observe the intestine shows pendular rhythmic movements under normal conditions, evident from the pattern of tracings. After that, inject 0.1 ml stock solution of acetylcholine in the reservoir, that is in the organ tube, and record the contractions for 30 seconds. You will observe the upward movement of tip of the frontal writing lever. This indicates that increase in tone and contractility of preparations. So therefore we can say that atropine shows spasmogenic action. After that, allow the preparation to relax by rapidly washing with fresh quantity of thyroid solution to wear off the effect of acetylcholine. Now record the normal pendular movements. After that, inject 0.1 ml of stock solution of barium chloride and observe the response. You will observe that increase in tone and force of contraction as evident in the stressings. Therefore, we can say that barium chloride also shows spasmogenic action. After, allow the preparation to relax by washing with fresh quantity of thyroid solution to wear off the effect of barium chloride. Again, now record the normal pendular movement once again and inject 0.1 ml stock solution of atropine followed by 0.1 ml stock solution of acetylcholine. That is the combination of atropine and acetylcholine dose, that is 0.1 ml each, and record the response for 1 minute. You will see the preparation shows normal pendular movement. That means it indicates that acetylcholine in presence of atropine does not show any change in the normal pendular activity. Therefore, we can say that atropine nullify spasmogenic effect of acetylcholine and acts as a antagonist of acetylcholine. Now relax tissue properly and again record normal pendular movements. After that, inject 0.1 ml stock solution of adrenaline and record the response. You will observe the preparation is now relaxed, evident from the reduced tone and force of contractility. Hence, we can say that adrenaline acts as a smooth muscle relaxant. So, this is a stepwise procedure of today's practical. Now, we will watch the video of today's practical. So, video of total procedure.
To study the effect of spasmogens and relaxants on rabbit intestine, isolate the jejunum of small intestine. Clean the contents of jejunum with thyroid solution in a syringe. Avoid any damage to smooth muscle lining of jejunum. Take a piece of jejunum about 2 to 3 cm long. Ensure the lumen of the jejunum is clean and open. Tie the thread to the top and bottom ends of the jejunum loosely. Ensure lumen remains open. Now mount the preparation in organ bath containing thyroid solution. Maintain the temperature of water bath at 37 degrees centigrade. Aerate the muscle preparation with aerator. Now stabilize the muscle preparation for 30 minutes under a tension of 0.5 to 1 gram. During stabilization, wash it with fresh quantity of thyroid solution for at least 4 times. Now start the drum. You will observe the intestine shows pendular rhythmic movements under normal conditions evident from the pattern of tracings. Now inject 0.1 ml of stock solution of acetylcholine in the reservoir. Record the contractions for 30 seconds. You will observe upward movement of tip of the frontal writing lever. This indicates increase in tone and contractility of the preparation. Therefore, we can say acetylcholine shows spasmogenic action. Allow the preparation to relax by rapidly washing with fresh quantity of thyroid solution to wear off the effect of acetylcholine. Record normal pendular movements. Now inject 0.1 ml of stock solution of barium chloride and record the response. You will observe increase in tone and force of contraction as evident in the tracings. Therefore, we can say barium chloride also shows spasmogenic action. Allow the preparation to relax by washing with fresh quantity of thyroid solution to wear off effect of barium chloride. Record normal pendular movements once again. Now inject 0.1 ml stock solution of atropine followed by 0.1 ml stock solution of acetylcholine. Record the response for 1 minute. You will see the preparation shows normal pendular movements. This indicates acetylcholine in the presence of atropine doesn't show any change in normal pendular activity. Therefore, we can say atropine nullifies spasmogenic effect of acetylcholine and acts as antagonist of acetylcholine. Relax the tissue properly and record normal pendular movements. Now inject 0.1 ml stock solution of adrenaline. Record the response. You will observe the preparation is now relaxed, evident from the reduced tone and force of contractility. Hence, one can say adrenaline acts as smooth muscle relaxant.
So this is the video of stepwise procedure of today's practical. So next is observations. Now we will discuss the observations of today's practical. So first of all, acetylcholine. So we have given 0.1 ml acetylcholine dose. So after administration of acetylcholine, it shows stimulatory effect, that is height of graph becomes increased, and that indicates that acetylcholine shows spasmogenic action. So look at this graph. So this showing normal and acetylcholine effect at the dose of 0.1 ml. So for normal, the graph shows pendular movement, and after administration of 0.1 ml of acetylcholine, there is increase in the height of the graph. Hence, we can say that acetylcholine shows spasmogenic action. Then second, that is barium chloride. So barium chloride also showed smooth muscle contraction, that is stimulation of smooth muscles. So look the graph again. Normal, it shows pendular movement, and after administration of 0.1 ml of barium chloride, again increase in the graph height, that we can say that barium chloride shows spasmogenic action. Next, we will discuss about atropine followed by acetylcholine, that is the combination of atropine and acetylcholine, 0.1 ml each. See the graph. Normal, it shows pendular movement, while after administration of atropine and acetylcholine, 0.1 ml each, it again shows pendular movement. That means atropine, which shows antagonist of acetylcholine, means atropine nullifies the action of acetylcholine. Next drug, that is adrenaline. So after the administration of 0.1 ml of adrenaline, it shows relaxation of smooth muscles of intestine. So look at the graph. The normal, it shows pendular movement, and after administration of 0.1 ml adrenaline, there is decreased in the stressings of graph. That indicates adrenaline relaxes smooth muscles of intestine. Hence we can say that adrenaline shows relaxant action.
You have learned that cholinergics are spasmogenic and anticholinergics are antispasmodic. Sympathomimetics or adrenergics are smooth muscle relaxants.
So next, what you have learned that, so from this practical we have learned that cholinergics are spasmogenic and anticholinergics are antispasmodics. And next, sympathomimetic or adrenergic drugs are smooth muscle relaxants. So here is the end of our today's practical.